Yes, single conductor USE-2 cable can be used to run from the photovoltaic panels into a weatherhead and through a short conduit run of 6 feet or less to the combiner box. USE-2 cable is a type of underground service entrance cable that is specifically designed for outdoor use and is resistant to moisture and sunlight. It is crucial to ensure that the cable is properly sized for the current and voltage of the photovoltaic system and that the conduit is properly sealed to prevent moisture from entering. When working with electrical systems, especially solar photovoltaic systems, safety is paramount. Always consult the National Electrical Code, or NEC, and local electrical codes for specific requirements in Vermont. Proper planning and execution are necessary to ensure a safe and reliable solar installation. Firstly, consider the cable type. USE-2 cable is designed for direct burial in earth or for use in ducts or raceways. Its insulation is typically cross-linked polyethylene, or XLPE, which provides excellent resistance to moisture, abrasion, and sunlight. Because it is rated for wet locations, it's suitable for running through conduit from the solar panels to the combiner box. Secondly, sizing the cable correctly is important. The ampacity, or current carrying capacity, of the USE-2 cable must be adequate for the maximum current that the photovoltaic array can produce. This involves calculating the short-circuit current of the array and applying a deterring factor, typically 1.25, as required by the NEC. For example, if the calculated short-circuit current is 10 amps, the cable must be rated for at least 12.5 amps. Thirdly, select the correct conduit. While a short run of 6 feet or less might seem insignificant, the conduit serves an important purpose in protecting the cable from physical damage and environmental factors. Electrical metallic tubing, or IMT, or rigid metal conduit, or RMC, are common choices. PVC conduit is another option, but be mindful of temperature limitations, especially if the conduit is exposed to direct sunlight. Fourthly, the weatherhead is a crucial component. It provides a weatherproof entry point for the cable into the conduit. Ensure the weatherhead is properly sized for the number and gauge of the USE-2 conductors and that it's securely attached to the conduit. Fifthly, sealing the conduit is essential to prevent moisture from entering the combiner box. Use appropriate sealing fittings and sealant to ensure a watertight connection at both ends of the conduit run, where it enters the weatherhead and where it enters the combiner box. Sixthly, grounding and bonding are critical for safety. The photovoltaic system must be properly grounded according to NEC requirements. This includes grounding the equipment, such as the metal frames of the solar panels and the combiner box, and bonding all metal components together to create a low impedance path for fault currents. Seventhly, consider the voltage drop. In longer conduit runs, voltage drop can become a concern. While a 6-foot run is unlikely to cause significant voltage drop, it's still important to consider, especially if the photovoltaic array is located far from the point of connection to the electrical system. Use a voltage drop calculator to verify that the voltage drop is within acceptable limits. Eighthly, labeling and marking are important for identification and safety. Clearly label all components of the photovoltaic system, including the combiner box, conduit, and wiring, with appropriate warning labels and voltage information. This helps to prevent accidental contact with energized components and ensures that qualified personnel can safely work on the system. Ninthly, consider the NEC requirements. Article 690, 1 of the NEC covers solar photovoltaic systems. Familiarize yourself with the specific requirements related to wiring methods, overcurrent protection, grounding, and disconnecting means. Tenthly, permits and inspections are generally required for solar photovoltaic installations. Contact the local building department to obtain the necessary permits and schedule an inspection to ensure that the installation complies with all applicable codes and regulations. When installing the USE-2 cable, ensure that it is properly supported within the conduit. The NEC specifies the maximum spacing between cable supports, which may vary depending on the size and type of conduit. Use cable ties or other suitable supports to prevent the cable from sagging or rubbing against the inside of the conduit. Furthermore, when terminating the USE-2 cable in the combiner box, use appropriate connectors that are rated for the size and type of conductor. Ensure that the connectors are properly tightened to provide a secure and reliable connection. Loose connections can lead to overheating and arcing, which can create a fire hazard. It is also important to protect the USE-2 cable from physical damage during installation. Avoid pulling the cable too tightly or bending it sharply, as this can damage the insulation and reduce its current carrying capacity. Use appropriate pulling lubricant to reduce friction and make it easier to pull the cable through the conduit. In addition to sealing the conduit, consider using a drip loop at the weatherhead to prevent water from running down the cable and into the conduit. A drip loop is simply a loop of cable that hangs below the weatherhead, allowing water to drip off before it enters the conduit. The combiner box itself should be rated for outdoor use and be installed in a location that is protected from direct sunlight and extreme weather conditions. The combiner box should also be properly grounded and bonded to the grounding electrode system. When working with solar photovoltaic systems, it is always best to err on the side of caution. If you are not comfortable working with electricity, hire a qualified electrician or solar installer to perform the installation. They have the knowledge, skills, and experience to ensure that the system is installed safely and correctly. Keep in mind that solar photovoltaic systems can generate high voltages, even in low light conditions. Always disconnect the system from the grid and turn off the main disconnect switch before working on any of the electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect yourself from electrical shock and other hazards. Also, consider the environmental conditions in Vermont. Snow and ice accumulation can put a strain on the solar panels and wiring, so it is important to choose components that are rated for these conditions. Regularly inspect the solar photovoltaic system to identify and address any potential problems, such as loose connections, damaged wiring, or corroded components. Promptly repair any problems to prevent them from escalating and causing more serious damage. The specific requirements for wiring solar photovoltaic systems can vary depending on the local codes and regulations in Vermont. Contact the local building department or electrical inspector to obtain the most up-to-date information and ensure that the installation complies with all applicable requirements. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or solar installer before performing any electrical work. Firstly, choose the right weatherhead. Select a weatherhead that is specifically designed for use with conduit and that is sized appropriately for the number and size of conductors you will be running. The weatherhead should be made of durable, weather-resistant material and should have a secure connection to the conduit. Secondly, install conduit properly. Ensure the conduit is securely fastened to both the weatherhead and the combiner box. Use appropriate conduit fittings and straps to support the conduit and prevent it from sagging or moving. Make sure all connections are watertight to prevent moisture from entering the system. Thirdly, pull the cable carefully. When pulling the USE-2 cable through the conduit, use a pulling lubricant to reduce friction and prevent damage to the insulation. Avoid pulling the cable too tightly, as this can stretch or damage the conductors. If necessary, use a cable puller to assist with the pulling process. Fourthly, terminate the cable securely. When terminating the USE-2 cable in the weatherhead and combiner box, use appropriate connectors that are rated for the size and type of conductor. Tighten the connectors securely to ensure reliable electrical connection. Fifthly, seal the weatherhead and conduit. Use a silicone sealant or other suitable sealant to seal the weatherhead and conduit connections. This will prevent moisture from entering the system and causing corrosion or electrical problems. Sixthly, ground the system properly. Ensure the solar photovoltaic system is properly grounded according to the NEC and local electrical codes. This typically involves connecting a grounding conductor from the combiner box to a grounding electrode, such as a ground rod or metal water pipe. Seventhly, label the system clearly. Label all components of the solar photovoltaic system, including the weatherhead, conduit, combiner box, and wiring, with appropriate warning labels and voltage information. This will help prevent accidental contact with energized components and ensure that qualified personnel can safely work on the system. Eighthly, inspect the installation thoroughly. After completing the installation, inspect all components of the system to ensure they are properly installed and connected. Check for any loose connections, damaged wiring, or other potential problems. Ninthly, test the system. Before energizing the solar photovoltaic system, test the wiring and connections to ensure they are properly functioning. Use a multimeter or other testing equipment to verify that the voltage and current are within acceptable limits. Tenthly, obtain permits and inspections. Contact the local building department or electrical inspector to obtain the necessary permits and schedule an inspection of the solar photovoltaic system. This will ensure that the system complies with all applicable codes and regulations. Understanding the nuances of the NEC is crucial for safe solar installations. NEC Article 690(31) addresses wiring methods specifically for photovoltaic systems. It emphasizes the need for conductors to be suitable for the environment, including exposure to sunlight and temperature extremes. Given that the USE-2 cable is sunlight resistant and rated for wet locations, it aligns well with these requirements when installed in conduit. Also, Section 310.15 of the NEC details the requirements for ampacity of conductors. Always refer to the appropriate ampacity tables, such as those found in NEC Table 310.16, and apply any necessary directing factors based on ambient temperature and the number of current carrying conductors in the conduit. It is imperative that the USE-2 conductors within the conduit are properly supported as per NEC Section 300.11, which focuses on securing and supporting wiring methods. Ensuring that the conduit itself is adequately supported, using appropriate straps or clamps, prevents stress on the conductors and connection points. Finally, ground fault protection is a critical safety aspect covered in NEC 690.35. While the conduit run may be short, ensuring proper grounding and bonding of the combiner box and all metallic components significantly reduces the risk of electrical shock.